Alright, welcome back. Let us continue with our study of classes. And we just started to get fancy with it, and there is some more terminology we need to learn. But first, let's practice what we know and recreate our counter library that we did when we were first learning about functions with classes instead. We can now finally fully recreate that example that I gave at the start of the class. Okay, so a counter is every counter object should have a count inside of it, right? So should just be one member variable probably, the current count, which we can make an int just like we did back in the day. And well, oops. Then we need to talk about the operations that you can do to a counter. And those are exactly what we had last time. We need to be able to initialize it, to reset the value to maybe a certain value. We can have it be parameterized. Increment, decrement the count, and then get it back. Oh man, I was showing you getters, wasn't I? Okay, so here's the idea. Let's first make an init counter. Maybe we'll just call it init, and then a reset with a new count variable, perhaps. That would help. So this is like a setter. And then we can have inc, dec, and get count. Okay, so is that all we need? I think so, at least for now. So let's go ahead and get this implemented. I'll save this. I'll call it counter.cpp, and we'll do it the lazy way for now. So here's all the things I need to remember. I'll just comment it out. I'll say class counter. Alright, what does it need? It needs a count member variable, and we're going to make that private. Okay? We don't want the user to access this. Because, for example, we want them to be able to only reset to positive values, something like that. So we don't want to give them uncontrolled access to the data inside of a counter. Now remember, the data inside will look like this. It's going to be, when you say counter C, it makes an object called C that holds inside of it a count. Okay? And then we're going to have associated methods with this counter class that if we say C dot, I don't know, inc, it will change the count from, say, 0 to 1, something like that. Okay, so that's our idea of a counter. Every counter has a count associated with it. That's a member variable that we want to keep private. And then the public stuff is going to be the init function, the reset function to another count, int new count. What else was there? Inc, dec, and get count. So inc, dec, and get count. And what should the types of all these be? Well, init's just going to set stuff. It's going to set count to 0. So we'll make that void. Reset is going to just set count. So it's void. Inc is going to set count to be the next number. So void. Dec is going to set count to be the previous number, so void. And then get count is going to just give back the count, so it's going to need to finally return something because it's an int count, so we'll return an int. Okay, so these are our functions. Do we want to be lazy and implement them here? Yeah. Let's be slightly less lazy. Let's implement them out here as one does. Okay, so the way we do it is we say, whose function is this? This is counters functions. Okay, those are their real names. It's not just init. It's not a normal function. It's counters init method. Yeah. And so then, if I say this, it should look prettier. And init should start off the count. Okay. And so it should make its count equal to 0. And I think before we go any further, let's use an example. Let's write an example to make sure that it's all going to work in the end, something that we can work towards. Okay. So we'll make a counter C, and we'll be like, okay, the first thing we need to do is initialize it. Okay, so we'll say c.init. So that should set the count to 0 if we were to print it right now. Should be 0 if we did it right. Then we can say c.inc, and we'll do that 3 times, and after that we'll do dec. So at the very end, if we output the count one more time, it should be, well, it was 0, 1, 2, 3, 2, so it should be 2 here. Yeah? And then we can reset it, check if that's working. C.reset to maybe, I don't know, 42. Make sure we get back 42. And maybe if we try to reset it to something stupid like negative 542, the count should still be 42. So maybe we won't change the count if it is a silly number. Yeah, I think that's a good strategy. Okay. So in theory, we should get all this stuff to print in this way, and let's implement all these functions to make it so. So reset's going to reset the count to be the new count. So reset the current object's count to new count. So the example of that is, well, I had my counter C. If I say c.reset 42, we want to go in and change the count of that object C to 42. Yeah? So it's going to go inside, change the count. Equals new count. But we only want to do this if it's not a silly number. So only reset the count if it's non-negative. Okay? That's the idea. So if new count greater than or equal to 0, in that case I'll set the count. Okay? And so this is one of those times where I'm using an if statement and I'm not using any braces because there's only one line in the body. That is allowed. Okay? Don't know if I've ever said that before, but I want to highlight it. You should definitely always use braces though when you're starting out. Okay. Increment is going to increase the count. Decrement is going to decrease the count. But we should also check to make sure it's not a silly count anymore. So we don't ever want our count to be negative. So if it happened to become negative after calling dec, we need to set it right back to 0. Okay? We'll be like, no, you tried to become -1, we're not letting you. 0 for you. And then get count just returns back the count. So again, this private member variable saved the day because now that we can't access count down here, we can't be like c.count equals -42, we'll never get the problem of setting the count to a negative value. That is our invariant. That never happens. Okay? It's a private member. Can't do it outside of the class. Okay, so that in a nutshell is the counter class, and let's watch it work. All right. So did we do everything proper? 0 to 42, still 42. Looks right to me. Awesome. So I hope that's making some sense. That's just a quick review of all this stuff. And before we move on, I just want to tell you a little secret. Every method, like when I say c.reset 42, it's really just a regular function. This reset method in quotes. We call it a method, but it's secretly just a function that gets a secret parameter, which is the object itself. So really deep down inside of C++, this gets translated to, when it's compiled, a function that looks like counter underscore reset, something silly that it knows it's the counter's method, and then it gets translated into C being the first parameter, and then 42. It secretly adds one there for you. Okay? So it's like there's always, the method is really a function, but there's a special first parameter that is the object you're calling the method on. Okay? So that's a secret thing, and just wanted to tell you that, just in case this was trying to look too magic in front of your eyes. That is, it's not really a magic thing. It's just a quirk of the compiler. It's being nice and letting you think of things as objects, when in reality, it's just, at the end of the day, it's a bunch of functions being called on structs. So a class is really just a struct, kind of. Okay? So with that, I want to talk about something called a constructor. So what if I forget to call init on a counter? What happens? Well, think about it. If I never call init, that means I'm never setting boop, 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 the count to 0. What happens, like if I say int x, semicolon, it makes an x with a random initial value because it's undefined. Undefined behavior, it could be any value that's sitting in memory. The same is true for class types. So if I say counter C, well, sure, it's a counter, so it's got a count inside of it, but that value is uninitialized. You see that? So we need to always remember to call init, and we might forget. And if we don't, it's going to be set to really weird things. So, for example, it's very possible that it will be okay on my machine if I comment this out. We'll find out. But you cannot rely on it. Okay? Yeah, so it's set to something random and stupid initially. Okay? That's the idea. So we have to somehow remember to always call init. C++ gives us a way to never forget. It's called a constructor. It's a special method that gets called for you whenever you make an object. Okay? So it's a special method and it has a special name. So it just so happens to be the same name as the class. So the method that is called a constructor, it depends on the class. So if it's counter, the constructor's name is counter. Isn't that interesting? So watch me change this. I'm going to change init to, actually, let me copy this, counter.cpp to counter with init.cpp, just so that you have that. Then come back, and I'm going to change this init to be counter. And because this is a constructor, and it's always making a counter for you, there's no need for a return type. You're making the class itself, so it doesn't need to be void. It's just called constructor. It has no return type, which is a new thing, okay? This is a constructor. And I think that's where I want to leave us for now. So let's call this counter. It's the counter's constructor. So its job now is to set the count to 0. So it's counter's constructor. So we'll say it like this. We'll define it outside. Counter, : counter. Okay? count equals 0. This is the constructor. So it's a method called counter belonging to the counter class. It has no return type. All it does is it sets the count to 0. All right, so that's beautiful. Now it's getting called for you whenever you make a new object. So this line itself will call the constructor. Dun dun dun. Gets called here. Okay, so right there is where the constructor gets called. And so right here. So this line both makes memory for a counter and calls the constructor to initialize the counter. And I know what's about to happen if I put this on that line, so let's fix that now. All right. So for free, just by making this thing called the constructor, the count always gets set to 0 for us. Okay, so there's no other change. It's just magically calling the constructor. Beautiful, and it works just fine. Okay, every time. There we go. So constructors are super nice, and they're for initialization. Now, we can get fancier with initialization, and I do want to do that. But let me just say right now that the constructor can take parameters, and you can have multiple constructors. So you can call the constructor in a different way when you're making a thing. Okay? When you're making a counter, when you're making a point. And there's a special name for the one that doesn't take any parameters, the one that we just made. It's called a default constructor. Okay? So this one, right here, it's called a default constructor. We can make another one. We can be like, this constructor takes an int. That'll set the initial count. So there's another way to start off this counter. And this is going to get interesting. Oh no, why did you do that? No, it's because of the comment. It's always because of the comment. No! There we go. Better. Okay. Are you ready? Nothing real different. All it does is it goes and sets the count to initial count. And the way you can use this is, instead of saying counter C like that, which calls the default constructor, you can say counter D, and then you give some parentheses. This is how you call the constructor. Okay? You'll say 4,321. Okay? And it will set the count initially to that, because that's what the constructor does. Okay? So it takes a parameter, actually. And that's the thing that you want to set. And you can make as many constructors as you need. Okay? It's beautiful. All right. So what happens if you have a class, I'll call it C, you make an object, I don't know, called obj of that class, and inside of that you have some other classes. You have some private member variables that are themselves classes. Maybe it's like a vector, maybe it's like a string, maybe it's a counter, a point. What if you want to initialize them by calling their constructors? That is a bit fancy, okay? And so the way you do that is you use an initializer list. And this is, you also need to use this thing called an initializer list if you have a const member variable that you need to set, because you need to immediately set a constant. It's like a constant C. You need to always make it 42. Well, once the object is made, it's too late to say object.c equals 42 because it's a constant. You can't reset it after it's been made. Okay? So you kind of have to do it before all that happens. Okay. And it appears that my tablet just stopped working, so I'm going to unplug this and see if it fixes itself. Otherwise, I'll have to restart this video. That's fun. No, it's not happy. Sorry, I'll have to restart my computer. Okay, I am back and hopeful that it's going to last until the end of this lecture. So we were talking about initializer lists and all this fancy syntax. It looks really weird. The use cases look really weird. And really this is a CSCI 41 topic. I'm not really going to test you on needing this, but it's good to know that it exists. So let me show you just an example of why it might be nice. So first of all, let me show you constructors that are useful. So for example, if you had a vector, you can initially make a vector in a special way. You can be like, I want a vector of ints. I'll call it v, and I want it to start out holding 142s. Okay? Which is super nice, and that, I mean, that's hard to do. Otherwise, you'd have to be like, okay, v equals 42, 42, 42, or you have to make a loop to push it back 42 times, or no, 100 times. No, we don't like that. Let me show you that it's actually working. I can say, dun dun dun. Here are the 142s that I'm about to print for you. So that's super cool. Hey, okay, so just to prove that it worked. And then also, if I make a constant, I need to set it immediately. Okay, I can't waste any time. So the one issue with constructors is in the body, it's too late. Okay, so let me make just a simple class. I'm going to call it foo. It's going to hold some silly things. I'm just going to make them all public for fun. It'll hold a vector. Will be one of its member variables. And it'll hold a const double blah. Okay, those will be its two member variables, and here in my constructor, or sorry, foo is its name, I'm going to set these values, and I'm going to be lazy, so I'll just implement it in here. I need to set these values, okay? So I'm actually going to get a compile time error if I try to make a foo f. So this will call the constructor. So get here and do absolutely nothing. And so v and blah are not taken care of yet. It's going to be like, well, first of all, I seem to have forgotten a semicolon somewhere. So where did I mess that up? Line 10. Oh, yep, right there. And then now, it's like, uninitialized const member in here. So it's like, blah, it needs to be set to something. It's a constant. You can't change it later. It needs to be initially set. So, all right, I'm going to set blah 2, 3, 4, 4. Sure. And then it's going to tell me assignment of read-only member variable. It's too late in the body to set blah. Okay? So it's like in between the constructor call in the body blah gets set. Okay? It's too late to try and set it in the body itself. Same for v. So v also got made before the body happened. So too late. for this, and then also v is going to get made. If I see out v's.size, it's going to be set to an empty vector. Okay, so let me comment out the blah so this will actually compile, and you can see the fact that v is going to be empty. Oops. There it is. It's of size 0. So it's too late. It's too late for all this stuff. It's too late to set blah. It's too late to set v to something special to call vectors constructor. So where do you do it? You do it right here, before the body, but after the parameters. And the secret is, look for the sad face. Remember the sad face. Okay, and that will solve all these problems. So right here is where you can make a bunch of constructor calls and set things. And you can set normal things using this constructor style syntax, in fact. So I'm going to set right here, colon, I'm going to say that v, I'm going to call its constructor. Start out holding 142s, please. And then comma, blah, I need you to start out being with 3.14, please. That's where you put this stuff. This is called an initializer list. It comes before the body and after the parameters, after a colon. Okay? So now, not only is the vector set properly, also blah got set to what we wanted it to be. Okay, so you have to use these initializer lists if you want to set, if you want to call a vector's constructor, if you want to call a member variable's constructor in your own class's constructor, and then also to set a constant variable. You'll read about this in your book. I just wanted to give you a heads up. Okay, so that is initializer lists in a nutshell. It just needed an example. It's not really too bad. Oh, and the reason that you can do this for anything is that's an alternative way of setting things. Like if you had an int x, instead of saying int x equals 42, I can say int x 42. That's constructor style syntax. Initialization using this kind of style works even for primitive types that are not classes. And you know that ints aren't classes. You can't be like x dot something. Okay, and that's the reason this syntax up here will work even for an int. You want to set an int. It's totally fine. Can I edit counter.cpp? So remember this. I can now, instead of in the body, set the count to initial count. I can be like, count set to initial count, please. And then that can be empty. And it'll do the same thing. All right. Beautiful. Yeah, that's essentially the bulk of that. That was probably the hardest topic. Okay, the rest is not too bad. Namespaces and the scope resolution operator, we've already touched on this. Every class gets its own namespace. That's where its functions live, its member variables live. Those two colons, that's called the scope resolution operator. And so the entire point of a namespace is so that you can make two things with the same name and not have those names clash. Oops, two names. With the same name and not have the names clash. So for example, let me show you this. Let me make namespaces.cpp. I'm going to make a foo function that returns 42, and I'm going to make a foo function that returns 43. And I'm going to try and compile this. It's like redefinition of foo. They both have the same name. How can I differentiate them? I know. I'll put them in a namespace. And you know what namespaces are. You've been using standard this whole time. Namespace N1. So namespace foo42, perhaps we can call it. And inside of that namespace, I'm going to put this one. And then I'll make a separate namespace, foo43, and I'll put this one inside that. Yeah? Now they can coexist. Whee! That's beautiful. It looks like it added some extra stuff for me, which is nice. Can I section this off with some more lines? Or is it going to take those away from me? Nope, I can do it. Okay. That's prettier. This actually compiled. There's nothing to run yet, though. The idea is these now can coexist because they're in namespaces. All right, they're in two separate places in memory, and their names are different now. So if I want the first foo, its full name is foo42 : foo. Okay, and likewise for this one. I think you know what to do here. So I can say cout foo42 foo, foo42's foo, and that'll give me back 42, and this one will give me back 43. So you can make a bunch of namespaces and put things with the same name inside of them. So it sections off those things. That's all. Oops. I want it to be called /namespace. There we go. 42 and 43. Not too bad. And I guess the only thing I need to tell you now is notice that every class gets its own namespace. That's how this works. That's how methods work. Okay, that's all. All right, finally, operator overloading. So this is one fun topic. C++ is translating more things. Just like it translated these method calls to really function calls with a special first parameter, operators like plus, minus, times, divide, whatever you want. Technically, this is an operator that you use on cout. There's a bunch of different operators that we've talked about, and in C++, if you have two objects that are not primitive types, that are like classes, strings, points, counters, whatever, if you say C1 plus C2, C++ translates that into C1 dot operator plus C2, or alternatively, C1 operator plus C1 C2, whichever one exists. That's what I should say. And the font is going to be wrong again. Oh no, no. This isn't a big deal, but one of these two is going to get called, and it's a special function. It's not plus anymore, it's called operator plus. That's the name of the method, or the function. I'm going to use this example. So if you want to tell C++ what to do to add 2 points, all you have to do is implement this method. /function. You could also do this way, but you can read about that way in your book. Okay, so this is going to be fun. Let me just make a simple point class. I don't think I am using points in this file. I'll say vim points plus.cpp. I'm going to make just a silly point class. Of course, I'm doing everything wrong here. It'll be like double x, double y. They'll be public, and then I'll say point operator plus, and then I'll give a second point, const point reference other. This could just be point other, But again, we like to take constant references as much as we possibly can. And yeah, that's essentially it. This will allow us to do the following. Point p1, p2, p1.x equals 1, p1.y equals 2, p2's x's, I don't know, 3 and 4. Yeah? How about that? So I've got 2 points, and I'm going to add them together into a new point. p3 equals p1 plus p2. And what this will do is this will call p1.operator plus, because p1 came first, p2. And we're going to implement that. And now the plus operation on a class that we made for ourselves will work. Isn't that cool? So let me comment this out and show you that you don't get one off the bat. You have to make one. And this is a very long error message, but again, it's like, I don't know how to do the plus, my dude. So you just give that plus. You're like, all right, I know how. I'm going to do it for you. So I'll make a point that we return back, and its x is going to be our current x plus the other's x, and same for y. And return that point. And that's how you add 2 points, C++. And then it will compile. I haven't actually done anything, so let me see out p3.x, comma space, p3.y, and we'll see if it actually worked. So these are little quirks of C++ that it's nice to know about. 4, 6. Oh man. 1 plus 3 is 4, 2 plus 4 is 6. We just made a plus operator for our class. That's beautiful. So, yeah, all you have to do is implement the operator that you want to implement. That's all. And there's plenty of these under the sun. And I guess the one that I want to give you now is one more, counters plus plus. Dun dun dun. And then also less than, for comparison and perhaps sorting. So let me do this. Let me go back to counter, and we're going to give it some operations. We're going to have, no more inc. We're going to call it plus plus, or we'll give ourselves options perhaps. And it's going to be operator plus plus, takes no parameters, returns nothing. And this is how you do it. You say void counter. Counter's operator plus plus does the same as inc. Add to the count. Yeah? And so now, everywhere that I used inc, I don't have to use inc. I could say, this is actually the pre-plus plus. I can say plus plus c. So I just implemented that operator. So now nothing's going to change. It's just going to call inc in a different way. It'll do the inc thing. Okay, and it works just the same, plus plus c now, instead of c.inc. Now we have options. Oh man. And then we can also do the less than operation on counters. Okay? Dun dun dun. We can say void counter operator less than, and it's going to need another counter. And oh, sorry, it's not void, it's bool. Is, so it'll get called like this. C1 less than C2. Will get translated into C1.operator less than C2. And we want to return whether or not C1 was smaller, and we'll return whether or not the count was smaller, okay? So C1 is ourselves right now, it's our current object. So return whether or not count is less than other.count. And what this gives me, I do need to declare it up here, the fact that it exists. what this gives me is not only can I say down here, I can say that is D less than C. I can ask that and print out the answer, or use it in an if statement. Not only can I do that, I can sort a bunch of counters. So I can say vector of counters v. I think I'll have to include vector, of course. I can say v dot push back d, v dot push back c, sort v dot begin, v dot end, dun dun dun, and I need to include algorithm. Are you happy now? And I can output, in sorted order, my counters. I know there's only two things. And v.add0 is a counter, so I need to output its count. Same with v.add1. That's all. And it will have sorted those, and I can sort a bunch of counters. Obviously 42 comes before 4, 3, 2, 1. All that sort needs to sort a vector of a bunch of things is a less than operator on those things. Okay. All right, pretty cool, huh? So, yeah. There are many operators under the sun. You could implement all of them. Operator star, operator less than, operator. You can even override this operator for whatever type you're using. It'd be like counter. Use this operation by, I don't know, with a 2 at the end, perhaps. You can use all of these. And one thing that's special for sorting for less than is that all C++'s sort function needs to sort a bunch of your own classes, your own class's objects, is a less than method / function. Isn't that cute? I love that. So I've just thrown a lot of information at you. I think I'm going to have to wait till next time for this extended example, but it's going to be really fun. We're going to draw on the screen. We're going to have like a little star that's bouncing around. It's going to go boop, 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 just like that Office video. Okay, so look forward to that. And in the time that we have left, I want to do mid-semester evaluations. I want you to look into this, and please, please, please do it if you can, if you have time. It's going to be anonymous, and so it's ungraded, but I would really appreciate it if you did it and filled it out. Okay, so it's down here. It's going to be under this week. Obviously, you'll see more things once I put them there. But it's called Mid-Semester Anonymous Feedback. And what it is, here, let me prove to you that it's anonymous. So you can write whatever you want. I won't know who did it. You can say what you want. Keep submissions anonymous. There it is. And this is what it looks like. I want you to fill this out. This is just for me. The college is going to give you one to do for the college, but this one's for me, and I'll get to see it before the semester ends, so hopefully I can fix a problem if there's a problem that you've noticed and that a lot of you are complaining about or something like that. Yeah, but I really encourage you to give me some feedback while there's still time for me to fix things. This will really help me improve the class for you and for my future students. So thank you in advance for that. And I think that's all I want to say. I mean, there's still some time, so let me give a recap of all that we did here. So what we did was, well, the last time we talked about const, that was it. We made a counter library, that thing from the very beginning of class. Finally, we did it. So we made this class called counter, and all it needed to hold was a count, but we figured out how to initialize it in special ways. By default, set it to 0, or given a special initial count that was non-negative. We can reset it, we can increment, or we can use an operator to do the same thing. Do the less than, to sort things, decrement, get the count back, that's a getter. And oh man, this probably should have been const, huh? It's good that we're going back over this. I guess technically this one's also could be const. Everything else changes things. Let's fix those. Const. Const. There we go. In theory, it should be happy now. And yeah, now we have a bunch of options. We can say, instead of c.inc, we can say ++c, because we define that operator. And we can sort, because we defined the less than operator. We can sort a vector of counters, because it will be able to compare those individual counters using the sort method, or the sort library function from C++. So that's beautiful. We talked about initializer lists. So in your constructors, sometimes there's some things that you need to set, and it would be too late to try and reset them in the body. So we learned how to use initializer lists to fix that problem. It's just that colon, make that sad face, start initializing things in between the parameters and the body of that constructor. That's all. We learned about namespaces, learned about how to make two functions with the same name and not have the compiler complain to us. So really, you can technically roll your own version of classes. Using namespaces, structors, and functions defined inside of those namespaces. So maybe think about how you might do that. And yeah, that was about it. Please remember to do those evaluations, and then next time I will come back and show you how to do fancy things, bouncing dots on the screen. Okay, so I'll see you then. Actually, I'll see you in your lab, so I will see you then.